Good afternoon and welcome to Design Master Training. My name is David Robinson. Today we are going to be looking at the generate command in Design Master Electrical RT. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So the topic of this training is the generate command, which is now found on the DM one line ribbon on this generate one line button here. What this will do is if you have your devices inserted in Revit in your 3D model, it will generate the single line in what we call a one line layout that looks like this, where it's kind of a top down view, starting from your utility transformer, going down to all of your devices. I want to point out that this is different from a riser view. So this is what we consider a one line. A riser for the same model would look like this. I've pulled this up in our AutoCAD software. We do have a command to generate a riser. We'll eventually get that written in Revit, but we don't have it yet. So a riser is where you're actually laying out your panels as they're kind of laid out in the building. So this is all the stuff on the first floor, the second floor, third floor here. So this is what a riser looks like. If you need a riser, you'll have to draft that manually in our Revit software. You can do that, totally possible, not a problem, but the software is not going to generate it for you automatically. So if you are looking for a riser, just know that this still needs to be drafted by hand. You're laying out the panels using our standard functionality to generate this. You can do it because it's just a matter of how you're drafting things, if you're drafting them in a riser or a one-line configuration. So we don't have the generate riser written yet. That's going to be in a future update. So if you need a riser, draw that by hand. What we're talking about is the one-line version, which is something that looks like this. So just keep that in mind that this generate command will generate just the one line. So this is what the generate command outputs. And as an example of how it works, I'm just going to start by erasing that whole thing. And I'm going to run the generate command and generate it from scratch. And it does take a moment to generate, because it's got to put everything in and then figure out where it all lives in Revit. But it does lay it out for you a little bit faster than you can do by hand. During the course of this training, I'm going to be erasing and running the generate command a lot. Generally speaking, you do not want to be doing that during your design. You want to run the generate command once and then make your modifications from there. If you're having to erase and run the generate a lot, something is off with your workflow. So please don't take what we're doing here as how you should actually implement this. I'm going to be doing that. And the one place where you would do it is when you're doing something like we're doing, where you're getting your customization set up. So you'll run the generate and say, oh, that didn't generate how I want it to. Make some changes to your customization. And then you could erase it, run the generate again and say, okay, now it's coming in right. Once your customization is set, in future projects, you shouldn't have to adjust them because they're set. And then the generate command will come out with as good as it's going to get, and then you work from there. And the idea being that you make your changes, you move things around, but you don't keep running the generate because then all those changes you've made are going to get lost. So we will be doing the generate command multiple times during the course of this training. But again, that's not generally the workflow you actually want in a standard project. You're going to want to run the generate one time and then make your modifications from there. So as you can see, it did insert everything for us, and that's the basics of the command. If you run the generate and pieces are missing, but some are in there, it will add in the pieces that are missing. So if we come in here and we just, again, you wouldn't normally do this, but for an example, say we removed those pieces there. So this isn't actually inserted because say you built out this part of your one line, and then you go add some additional stuff to your project. So you've added it in Revit, it's not on the one line. What you can do is you can run the generate command again, either from the very top. In this case, I'm just going to select this panel. It'll be slightly faster because it doesn't have to look as much stuff. And it will look for anything that's missing, and it will insert it for us. So it does have to think a little bit, but it will eventually figure out that there's some stuff missing, and then it's going to add it. So you can use this to get other stuff in there. And then once it's in, you can move it around. If you're adding stuff in the middle of a project, it's going to struggle sometimes to know where to put it. So you will have to do more adjusting of the one line. because it's not going to move anything else that's already there. So if there's no room, it's going to, again, do its best, but it's not going to be perfect. The one line that we generate has everything in it. It's, correct in terms of its information. It's never going to be correct in terms of the drafting. So assume that there is going to be a follow-up steps where you go and you modify things, add labels, move things around to make it look right. But it does get everything in there kind of as a first pass. When you run the generate command, there are a couple options here. There's not a whole lot going on in this command itself in terms of options. You can choose which device you're going to run the generate from, and it'll basically generate from that down. This is useful if you want to generate pieces of it in different places. We started here and just generated the whole thing, but say we wanted to move this whole section somewhere else, we could just actually erase all of this. And say we wanted to just generate that in another place, we could run the generate. This whole section is missing, and then we could generate this in another place. So you can generate pieces at a time and then kind of build them, put them back together later. So you have that option to do just a portion. And it'll start from there and work down. If there's anything upstream, it will make that connection for you. It'll draft in this feeder for us from here to there. When you run the generate, you can select from the tree or the list. You can also select from drafting view, and that's basically where you select something that's already inserted, and then it'll look for anything downstream that's missing and add it. We also have the panel edit button. So if you want to just, if for whatever reason you're starting to run and generate and realize you need to make a change, it'll pull up the panel edit command. Just another way to get here if you need to make changes. Other than that, those are all the options that exist in the command itself. However, there are a number of options on the back end to make all of this drafting look how you want it to look. First place we're going to look for those options are in project options itself. And we have down here at the bottom, the one line diagram, generate one line section. So all of these options are how we're going to control what this generate command does. The one line diagram options are also in play here. So we should just kind of start from the top. The feeder offset, that's how far apart we're going to draft any feeders by default. These numbers here are intended to be inches on the printed page. So it's going to be 0.3 inches apart. For the drafting here, mostly if we have to keep off of something like this feeder here, this is going to be 0.3 away from the edge of that panel. So we use that to kind of keep our feeders with some distance between each other rather than dropping right on top of each other. Then we have the default feeder and overcurrent protection graphics. And those aren't specific to our generate. Those are always in the one line commands when you're drafting stuff by hand. Those are the default segments going to be used for the feeders and for the overcurrent protection. So then the options that are specific to the generate are down here. We have the horizontal and the vertical spacing. This is going to adjust how the horizontal, how far apart we lay out these panels. So right now we've got 0.9 inches between them. And then the vertical spacing is 1.5 between them. And so this is kind of just a look and feel for how tight or not you like your layouts to be. If you get them too tight, it does have a little trouble drafting things. So the 0.9, 1.5 works out well. It's about as tight as you can get with our default graphics. If you make it tighter, things start to kind of run into each other. So we can actually test what that's going to look like. So we go to 0.5 and we'll go to 0.75. So now we're going to be much tighter on all of our spacing. And to save time, let's redo just this one section here. Generate just that panel, and let's see what that ends up looking like with those new spacing settings. So you can see it's putting the pieces quite a bit closer together vertically and horizontally. It works out generally with these larger panels where we've got space for the breaker inside the panel itself, and then we can make the connection down below. Where it does struggle is this connection here. In this case, you might not even want to show that breaker anyway, but things kind of start to overlap because there's not enough space between them. So that's why we have the default settings that we do, but you can adjust that to whatever you feel like gives you the best output given the settings that you have in your project. So we just give you some option for how you want that to look. We can also obviously make it bigger as well. So we go 1.5 and 2, it's going to be something bigger. And while I demonstrate that, I'll also demonstrate the next option, which is the circuit sort order. This is for how we are laying out these panels. Right now, it's in circuit order. So it's odd and then even in ascending order. So that's how we're going to do it based upon how they're actually connected in the panel. We'd have two other options. We can do it based upon the breaker size. So the larger breakers will be on the left, and then it'll be descending order to smaller breakers on the right. Or we can do it based on equipment name. So it'll be alphabetically from A to Z, left to right. Let's change this to equipment name for now. Click OK. So we'll notice that we've got M on the left, L on the right. So that's going to all flip. We'll erase all that. Actually, yeah, we'll erase the whole thing and we'll draw all that back in. And again, as a reminder, you generally aren't going to be erasing and generating as much as we are in this training. You do it when you're making changes to your settings to get your customization right. Once your customization is right within a project, it's not intended that you erase and generate as much as we are. So we have the wider spacing. Everything has a lot more room between it, which is going to make everything draft a little better. It also takes up more room on the page. So obviously there's trade-offs there. And then we can see left to right, we are now in alphabetical order for the ordering of all of our pieces. The other setting for the sort order is based upon breaker size. So we can change from equipment name to breaker size. What this is going to do is put this 125 amp breaker on the left and then all the hundreds after that. We'll erase everything down below and we'll just redraw all that. So when I run the generate, I can select from drafting view and say, okay, I want to redraw everything that's connected to this. So that's how the select from drafting view can work. If those project settings are chosen in our template file, will they carry through for all projects? They will. So this is a standard design master customization rules apply. So if you go to your project, a template, and you set project options in the template, it'll carry through to future projects. You can also import and export your project options from a project. So get one set, export it, and then import it to your other. So there's two ways to get your customization transferred between projects, either set it up in a template or use our export and import. And now that it is done, you can see that we've got the largest breaker on the left and the smaller breakers on the right. So that's the options that we have for sorting our circuits. We have the settings for all of the graphics that are going to be used by default for panels, for transformers, and branch circuit devices, and then broken up in a couple different categories. So for panels and transformers, it's based upon the number of things that they have they're feeding, the number of subpanels. And you can see that this is happening here, that this panel here has 2 or more connections, and this one also has 2 or more. So you end up with this graphic, and then there's nothing being connected to these. So that's the 0 or 1 graphic. So we have different graphics by default based upon the number of things that are being fed, because generally that's how people end up drafting their one line. They'll use a different graphic for those 2 different cases. Or if they do use different graphics, those are kind of how they split it out. You could set those to use the same graphic and that works fine. So for the 0 to 1 subpanels, we're using the panel fed from top. For the 2+ subpanels, we're using the switchboard, the horizontal fed from the top as well. For the transformer, we have the option for what the transformer is going to be. Again, you can change that graphic based upon the number of connections, or you can use the same. And in this case, we're actually using the same. So we're using the transformer, the box with the ground. That's the graphic that we've chosen. And then if you have any branch circuit devices, we have a graphic for that as well. So all of these options are set first at the project level. So for your project, you say, this is what we're going to do. And if you don't have anything else set, it's going to come in with all of these graphics. But sometimes you're going to want things to come in using other graphics. And we have a number of ways to set that in the devices so that the devices come in with different graphics. All right, so here's all of our 3rd floor equipment in our equipment room. I'm going to erase it off the model or off the single line. When we run the edit command, we can select a piece of equipment, and we have a one-line diagram section here that controls what graphics are going to be used. So the first option is whether we show it on the one-line diagram at all. That defaults to yes for electrical equipment. You can change that to no. So if you don't want to show something, you can set it to no, and it won't automatically generate it. So if you have things that are in the model that don't belong on the single line, you can turn them off. Then we have the defaults for the equipment and all of the upstream OCP, the downstream OCP, and the feeder ID. If I load all my panels, we can make some changes to the other pieces as well. So this is where you can say, okay, for this panel, rather than using that panel fed from top, maybe I want this one to show as a panel with a bus. So we can make that change here. And this MDP3, rather than a switchboard, the horizontal switchboard, let's do the horizontal with the tab fed from the top. So it'll draft just a little bit different. So you can choose different graphics. And then when it runs the generate, it'll know to use those different graphics. So there's a little bit of setup ahead of time so that when you run the generate command, it will come in with the right graphics. We'll just change the equipment graphics, and then we'll come back to the overcurrent protection. Make those changes, run the generate command. When we run the generate command, you can see that it's going to come in with slightly different graphics. So this one over here has the panel with the bus, and this one, you can't see it because it's hidden. There we go. Has the switchboard with the tab. So it's just a different way of drafting that switchboard. Different people have different ways of drafting things. We've got different stuff in the software. So we chose that, okay, this one's going to draft a little differently. It has this, this appearance. This one over here is drafting with the bus. So that's how you can adjust what comes, the graphics that they use when they come in. At this point, if we try and edit these and we try and change those graphics, it's actually not going to allow us, because it's saying it's already on the one line. It's already inserted. You can't, if you want to take it off, go to the one line and take it off there is what you need to do. And if you want to change the graphic, go to the one line and change the graphic there. So to erase it, you just erase it. To change the graphic, you'd use the add modify graphic. So if we wanted to change this graphic, we could use add modify graphic on the one line and then choose a new option here. And the reason we do it that way is that things do get a little bit weird if you start trying to change these graphics not on the one line. So we feel like once it's on the one line, it's best to go make the changes on the one line rather than through our other commands. That said, we do let you change the overcurrent protection and the feeder ID both before the generate and after the generate. So if you want to, you can come to this panel here and we can change the upstream overcurrent protection from a circuit breaker. We'll make it a double draw breaker. And then we can change the downstream overcurrent protection as well. We'll change that from a circuit breaker to a fused disconnect, or no, we'll do a fuse switch once it's done thinking about those graphics. When you make the change, it actually does go and update the one line automatically. So we'll change this to a fuse switch. And when we do that, it's going to change immediately. And this will change on the one line if it's already in there. It also, if you did this beforehand, before the generate, it would do it after the generate as well. So if we take a look, now we've got all those fuse switches, and way up here, there's the double draw out. So we've got the other breaker up there. And then also we can change the feeder ID. So if I go to this panel, we have the feeder ID. You can override that. We can make that a rectangle. All right, so that's how we can handle panels within the project. We can also go a layer deeper, and we can actually open up these families themselves. You can select the panel itself and run the edit family command. And now in here, you can run the design master family edit command. And you can say, okay, this thing is a panel. And when it is a panel, we have all of those options for the graphics that you can embed in the family itself. So if you have a bunch of stuff and you want to have it look differently on the one line, it's a little tedious in the project to go back and make all those changes. If you set it up in the family, that way when that family comes in, say we had an automatic transfer switch, you could have the automatic transfer switch come in and set the graphic that it's going to use is not a panel graphic, but actually an automatic transfer switch graphic. So you can tell it what graphic you want to use for 0 or 1 panel subpanels and for 2+ subpanels. And then also the graphics that it's going to use for the overcurrent protection and the feeder ID. So all of this can be set at the family, both for the entire family and then also for each individual type. So if you want to override it at the type level as well, you can do that. So we've got a lot of options in here for changing how these graphics are going to show up. So we'll take this one and let's change it. We're going to change this whole thing to the panel with bus because that will then be different. And if we have 2+, we're going to do the switchboard with the tab again. Then we can load this family into our project. And if we go to the one-line diagram, if I erase all of this and regenerate it, it's going to see that those ones should be using those new graphics. So it's going to draw them all with that new setting. So we'll run the generate. So you can set those graphics in the families themselves so that when your families go in, you have different graphics being used on the one line based upon the family that's selected. Likewise, for branch circuit devices, we can do the same thing. Going to right here, we've got this CTP cooling tower. I'm going to remove it so that we can make changes to it, and then we'll put it back in. If I go to my 3D view, that's that cooling tower. If I run the instance edit command, here we have the option for show on one line diagram, yes or no. This is actually set to yes. We've overridden it. By default, branch circuit devices are set to no. That way you don't get every single receptacle and light fixture on your one line device diagram because you don't actually want that. You just want your large motors on there. So you have to go in there and specify them either at the instance level. And again, we'll take a look at this in the family level as well. So you can say, okay, this motor connection always should show up on the one line. Let's change that in the family, or within the project, the specific ones, you can select them. You can set them yes or no. So we'll leave that as yes. That means it's going to show up on the one line. And then we have the option for the graphic. By default, it's using that equipment connection from the project options. We could change that. Say we want to show this as a motor connection. We can do that. And then when it goes in, it's going to use that motor connection graphic. You can also at this point change the overcurrent protection and the feeder ID as well. We'll make that one change. And then we will run the generate. And since that one has been selected as yes, it knows to insert that, but not insert anything else. So that's how that one branch circuit device is showing up, but none of the others are. You can set it in the 3D view. You can also make those same settings in the family as well. So if we run edit family, and then we run the design master family edit command, if we set this to an equipment connection, we again have the one line graphic settings where you can choose what you're going to use for this. So it's going to, by default, it uses the project, but then you can override it. You can say this thing, first of all, by default, it's not going to be shown, but I want to say, yes, I do want to show everything of this type on the one line. And then we want to use a junction box to represent it. And then every family will use that when it's doing the generate. So it'll know to automatically insert them, and then it'll know to automatically use the junction box. Load that into my project. I run the instance edit. We've actually overridden that. Actually, it's already on there, so it's already using this graphic, so it's not going to use that junction box. So if we erase it one more time, run the instance edit, change it from the motor connection back to family default, it sees that it's going to use a junction box now. And the show on one line, we can change that to family default as well. And so now we're using all the default values, but it knows to go in, to insert it, and to also insert it as a junction box. Generate, inserted it as that junction box. One question that comes up a lot is, how do we handle spare breakers? And the answer is that the generate command does not handle them. So there's no way to mark a spare breaker and say this breaker should be inserted automatically. So those you have to go back and add as a second step using our circuit insert command. Just keep that in mind. If you want spare breakers, they're not going to come in. We don't have any way to tag them to show up on the generate automatically. You just insert them as a second step using the circuit insert. We have new drafting options for top lug and feed through connections. So if you connect your devices as top lug connections or as feed through connections in Revit, our software will pick up on that and do the drafting on the feeder to match. And then we've got some settings on the families themselves to know where to make that connection. So if we go into this family and edit this family, you can see that we've got the general connections for the circuit breakers here, but we also have the top lug connections and then the bottom lug connections as actual output points. So that's how it knew to draft this part from here. And then if we actually go edit this family and make a bottom lugs connection or a feed through connection, change that to feed through and redraw that feeder, it will draft it from the lugs rather than from the bus bar. And that's used both during the generate command, and also if you're inserting stuff manually. So we just draw that connection by default from this location, so that it looks like it's a feed through. That is it for the generate command. Those are the options we have. That's how you can control the graphics that are going to come out. If you have any questions, feel free to throw those in the chat, and I will be happy to answer them. Either things related to the one-line generate command or anything else related to the software. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.